interdisciplinary. He genuinely gets the interdisciplinary angle, and not just within computing science and working with different types of computing science, but working across the board. And those researchers are really hard to find. His work, as I'm sure we'll learn more about today, looks at the human as well as looking at the development of the software, as well as thinking about the security angle. And all the work that Ali does has incredibly important impact. And one of the things, Ali, in our faculty, and we value in our department as well, is doing IT for social good, right? So that we choose questions and problems that actually we think will make a difference in the world. And your work resonates very strongly with our values, which is why it's another wonderful reason to have you here. The amount of publications you've gotten, citations, but grants and all the rest is just phenomenal. But I think even more important is the work that you do makes a difference. And I think that's so important. So I'm just going to move to our next part before we get Ali to talk and get you to all wait for the, star attraction here.
Good morning, everyone. And thanks, Monica and Mohammed, for the kind introduction. So just imagine that you are credit rating, researcher. And in order to do your research, and you have to provide your credential to one of the largest credit rating agency. And one day you get up and you get to know that along with the 150 million people, your credential has also been compromised. Just imagine you just got basically a service to run a Wi-Fi, and you have to provide your passport and your driving license. And one day you find the most critical, basically personal identity information has been compromised. And then on the top of that, you know that actually that was not the technical problem. That was a human problem. So Equifax forgot to patch their vulnerabilities, and Optus could not configure the APIs properly, right? So that's what I'm going to talk about, that looking into the socio-technical aspect of security patching. So, and then you talk about National Health Service, how many days the system was unavailable. And that was again, they could not patch. Actually, the patch was available and they just could not patch. And that's a basically classic health service, basically example, which we can relate based on our research, because we conducted research also with the Health Service Agency. So before we go forward, there have been a lot of kind introductions and everything. But if you see what I would like to be introduced, number one, I was qualified as a psychologist. Then I went to the business school and then I ended up in computing. So why interdisciplinary come very natural to me? There is a reason for that one. And when basically we talk about industry collaboration or running the industry research, that is again starting from my first basically endeavor in research. I work on a linkage project, working with the person who was actually funding the project from the industry side, defense side. Then I went to NICTA. I used, as a PhD student, I used to go to basically CBET kind of, that technology showcase kind of thing. Then, they meant me NICTA actually sent me on mini MBA because of the startup culture or everything. Moved to Ireland, Lero. That was all focused on Irish industry, but working with Rob Walsh in basically Germany, then working in Finland with the industry. Went to Denmark, got the basically one of the largest basically funding from strategic agency. And then I was 9 months in UK, and Avas pulled me into one GCHQ project. Actually, if we have taken the initiative earlier, I would have stayed back there. So after 6 months staying there, one day he asked me, I'm writing a proposal and I want you to be with me. I say, okay, but after 2 months, I was out of that Lancaster. And since I came here, I've been working with the different industries. And one of the, basically, I feel very proud of that, cybersecurity CRC. It's not that we got the funding and everything. I was one of the guys who was going to the companies that be part of this CRC, not with the glossy brochures, but 1-page PDF black and white printed thing, making of cold calls and saying there is an initiative on cybersecurity. Would you like to be part of that? So yes, I am a team lead. I'm a technical guy when I do the research, but that is, I was doing that. So if PhD students are sitting here, that is a part and parcel has been my, that my journey. Anyway, my research, the team which does the research, where I'm going to contextualize this is trustworthy digital services, what we focus on that. So it's a quite, basically wide variety of things we do at different, layers of the stack of the applications. So starting from our domain, we focus on health systems, ag-food system, and defense system. And then we apply data science approaches, integration and interoperability using semantic technology and other AI approaches. We are also in the autonomy, that's system. Then the technology, any emerging technology, we use it to design and develop the system, try to learn what kind of method, processes, and tool would be suitable in that respect. And for that one, we look into the continuous software engineering, which is a DevOps and no DevSecOps, model-driven engineering, then knowledge-based approaches to engineering these systems, and then socio-technical aspect of that, that's human factors. And everything we do is security by design now. And we do applied artificial intelligence. We don't develop machine learning or deep learning, natural language processing approaches, but we are heavy user of those approaches, and that's where we applied them in our research. So to make this one interactive, please feel free to stop and we can basically engage in the discussion because there are many slides I would be covering. So I might stop anywhere. I'm going to talk about context research. What is the context of this research? Briefly, I gave you some idea. Then why we think patch management is a socio-technical system. Then what research, questions we stimulated our research, methodological and logistical details, taxonomy, we have identified the reason for delay and we taxonomize that for better understanding, and strategy to avoid and minimize those delays, and what are the takeaways. One of the reasons we do empirical research is to inform the automation, to inform the artificial intelligence-based researcher that these are the requirements coming from the field rather than basically anecdotal evidence or just conceiving that this problem need a solution. So that means you already have a solution and say, okay, there is a need of problem. So just to warn you that I have tendency of choking when there is no much water. So no, Monica, don't worry about that. I will survive on that. I will try to slow down and I think it would be okay. Anyway, so I already mentioned to you that WannaCry, which impacted the National Health Service systems. After they suffered, the other organization, 2 years, they were still, going in the same direction, not patching on the time. Equifax, I just mentioned to you, they had the patch 2 months before somebody exploited the known vulnerability in that respect. Then cybersecurity can be the safety critical as well, because there is an instance of people dying with that. So the context is, patch management application of the security patches to identify security vulnerabilities in the source code. So this is a whole life cycle. Many of you are working here. I know, for example, Chakrat is here, Lily, then Shanxia. So prediction models start with that, for example. So that means first you build the model, you are discovery, exploit, disclosure, patch availability, and patch installed in that respect. No, we are not focused on the development of the patch. We are focused on when the patch has been developed, released, what organization do with this patch, what basically their life cycle is and why they fail to patch the software which is known to be vulnerable in that aspect. So that means if I'm a security guy, I know that thing, this patch, the vulnerability can be exploited. Hackers are also know that thing. Sometimes hacker know more earlier than basically the security manager would know that this is a vulnerability and which can be exploited. So this is a particular focus area we are working on, post-patch risk. So let's talk about briefly about the security patch management, where we are basically looking, targeting our research is retrieving the new patches. So there are multiple sources. Vendor will provide you, they have a newsletter, they have a mailing list. You might have a social media, like, I mean, that many organizations are doing the scan of the social media. There may be, some community-based, platform, malware, basically awareness, sharing kind of information. Then you retrieve them continuously, and then you see that one it's a difficult why we in timely manner don't get informed. Then we need to scan our system to identify where the vulnerabilities are in the system. And then based on that, we try to decide that, okay, we have detected the vulnerability. So one team will do that and they need to hand over that report to another team. Then we prepare for the patch installation, the patch prerequisite, basically investigation. So of course, we need to understand what kind of prerequisites are for those patches. Then prepare the machine configuration, patch dependency, and testing, patch testing in that respect. Then comes installation of the patch, time update to avoid disruption, coordinate with the stakeholders, internal and external. No, most of the security aspect have been outsourced to the specialized vendors. And then you need to coordinate with them as well. And then is handling post deployment issues, monitor patch status, then gather, client feedback, decision by organization. Now, each of these phase causes delay if they are not handled in a basically proper way. So that's I will talk with that, how meticulous planning and how basically careful execution is needed in order to make the patch, successful. And here we're talking about, it's a reasonably sized organization. It's an agency, health agency. They have 1,500 servers, which vendors need to patch on that one. Many of them are legacy, considered legacy system as well. But if you see the education system, right? A university with around 100,000 staff and kind of thing. Thanks. So basically, then you can imagine that how many, patch problem they would have. Okay. Socio-Technical system. So one thing I love about Lancaster is their software engineering. So this paper was written, I read this paper again by Ian Somerville, along with one of his, student, I think. So they mentioned that the first time socio-technical concept came by Emery and Trist. So according to them, a system with a complex interaction with human, machine, and context. So a system has a many interdependent internal and external parts. Consider basically within the context. So any system you're using, whether nowadays it's your mobile phone or it's basically smartwatch, they have basically internal and external part, and we need to consider them in their context. So designer and engineers can avail more than one path to reach. So that means design options are available. So then they need to do the trade-off analysis in that aspect. And then, system performance dependent upon a combination of technical and socio-technical system. No, unfortunately, most of the time, social aspect is not, it's not, considered. One thing is expensive. Many people will not realize that social aspect is expensive. You do that one and you would realize that social aspect is expensive. And sometimes we don't get funding for that because our focus is, and when we are operating the system, more or less same thing happen in the organizations as well. That means they focus on technical thing and they forget that thing. Actually, there is a social aspect as well, an organizational aspect in that aspect. So that's why we consider patch management is a socio-technical system, and we need to look into both social and the technical aspect together. So 6th question, drove our research in this area. So today I'm going to talk about only first two questions: why, how, where do delay occurs in software security patch management? How can the delay be mitigated? So there are some strategies as well, again, captured from the field. Then there are four other questions, and basically question number 3, interdependency of the coordination, and what is the theory of coordination in security patch management. These questions we answered in FSC paper in 2021. And the last two questions, what are the automation need and how to meet them, and how would human and automation interaction will happen. These are the last two questions answered in ASC this year conference. I mean, Nisara presented in Michigan, I mean, last week. So those, I'm not going to address these four last question. There is stuff, I mean, in the papers. Okay, so let's, I mean, basically, and then, you know, before we move, I hope I'm going fine on the time. So methodologies are very important, because if you see my background in psychology is, you know, I mean, convinced me that methodologies are important. And just, I mean, to a bit of sidetrack, that I was invited to give a keynote at the workshop, and I sent a bio, which I almost got myself uninvited, because bio was a bit more sarcastic, that because I said, I did empirical software engineering because I was trained in psychology. And I say, okay, so this is the way you do empirical software engineering. I have done that one. So anyway, so there is a detail. So then, yeah, host, I mean, kindly came back to me and said, you need to give proper bio for that. Okay. So anyway, so what we did, just to, it's a longitudinal study. We were fortunate that the security manager, you know, I mean, quite, I mean, he appreciated the research quite well. And we got access to what we needed in this particular scenarios. So you see, there are vendors. If you see on the right side, there are vendor organization, and there are basically the agency with which we are working. They have internal multiple teams involved in the security patch management, because there are different kind of systems, and there are different approving procedures because of the mission critical systems they are running. And then they have an in-house application developed, which they patch themselves, but at the same time, they have to rely on the vendors, like, I mean, Apple, basically Microsoft, or whatever their you know, that mean system providers are, operating system providers are. So 51 meetings were observed. I mean, you know, that, I mean, Nisara mainly did, I mean, basically observation of the meetings. Okay, there is a timeline. So there, and each meeting lasted 90 minutes. And then post meeting, we were again fortunate that they gave us a time, you know, after the meeting ended, they, for clarification purposes and all kind of thing. So again, they gave another extra 45 minutes on average to seek clarification, and what basically they discuss everything. And then we also, you know, I mean, analyze the patch minutes in that respect. Of course, I'm not presenting everything in this talk, but as I said, it was longitudinal study. Okay, so then where most of the findings today I'm going to talk about is coming from this slide data. So what we did, it's called patch tracker. So they do the patch tracking. You know, you see how critical systems are, and they're using spreadsheet, right? So it's not that as a criticism on them, it's the thing is the technological usage. They're using quite sophisticated system for providing the health service, right? But at the same time, how to run the system, they are very rudimental. So that means these should also be very sophisticated as well. So coming back to that, they have this tracking system, and we observe 4 years of tracking, and we only focus on the issues which had been closed. So that means we did not analyze the issue which were still open. So in the sense that total 232 issues were there, and out of that 131 were delayed. So that means 56% was the average rate of delayed patching. And remember, it's a security vulnerability. We are focused only on that. So we are not dealing with the regular patching, like, I mean, feature upgrades, error basically fixing, all kind of thing. We are just focused on the security patch in that aspect. So it's a quite significant. Then we also ask them what actually they estimate the time for each of the phase of the task. And they mentioned the patch information retrieval should be 2 days, then 2 weeks, 2 days, then vulnerability and scanning assessment almost 1 week, patching testing 1 week, patch deployment 2 weeks, and then post deployment verification 1 month. So from there, we analyze the data that how late they were in their patch basically thing. How are you going? Any questions so far? There are still 40 minutes. I'm here. Yes, please.
Wanted to say, oh, thank you. I didn't know you had a psychology background. That's wonderful. And, and yes, we are taught many methodologies, aren't we? Which is great. I'm just wondering in all of this, and maybe you're going to talk about it as you go along, about looking at the human in all of this. Do you think part of this problem of getting them to patch, like with the WannaCry virus, etc., is there a lack of understanding of what patching is done for? Because you were just saying, you know, it's the security versus the updating. You know, part of changing behavior means that people have to understand the reasons, not just be motivated, but understand why. And I might be fast forwarding you in this talk, but do you think there's an issue there at all?
Thanks for asking this question. And I think, I mean, for, that National Health Service, we have not looked into that case, but I would be addressing what you just mentioned. None of the delays are intentional. Actually, they are very meticulous. They understand their responsibilities. The nature of this thing is, at the same time, there is an element of fear that if we cannot bring this system back in time, because there is a window, patch window, and that is a very strict based on the different schedule of the operation, different schedule of the services. And the fear is that if we patch and the system is not coming back, or system basically, so what's going to happen? So that means it's a risk taking. Either you take that risk, or you take the risk, or you can just basically leave that, okay, hacker would not know that, and kind of thing. But I mean, I would get back to that, yeah. So, yes, please. So it's not operating now.
Thank you. So I just wonder if this observation in terms of the data collection is generic, or if this is specific to the industry, to this particular sector. Because one reason that I have this concern is that I saw a few other studies on a similar kind of topic to study on the delay in applying the security patches. So one study that I saw was on blockchain systems, because they are largely sharing the same code base, originally from Bitcoin. Then they are doing the hard fork and copy paste all the libraries and so on. And when there is a bug in the code, they all need to apply the patches. And the other one was on the SSH protocol. And Kenny Peterson had a study many years ago saying that, probably there are over 70% or 90% of the protocols in the world, they have some vulnerabilities. Then after another 10 years, when he looked back and did another large analysis on the SSH protocols, then all those security vulnerabilities were still there. So they were still not patched over the last, the 10 years. So I'm not sure what is the current state of those protocols, but it seems to suggest that it's not only, the human who are delaying the process for a couple of months, but there are some factors preventing them or encouraging them to not even consider to apply or follow up the patches.
Yeah, thanks. So exactly, basically there are factors. Number one, the study which I'm going to talk about is a very context specific. So that's mean all the, you can say, social aspect of studies or qualitative research, they are very context specific because it's a case study. But it depends on, if you say how the case study can be applicable. For example, Cuban missile crisis. That's the only one case study. But that's defined the whole international politics for the last 50, 60 years, right? So it depends. So what you are giving example, why the situation is still as bad as 10 years ago, because again, I mean, in the sense of lack of knowledge sharing, lack of appreciation, at the same time, training also come into the play. I mean, so I believe that, we have to train with the encouragement that people take risk, they make decisions, and then they are not punished for those decisions, not basically bringing the outcome in that way. So indecisiveness is not a solution anyway in that aspect. But I will cover, in that aspect. So there are quite a number, methodological details which we did. So for the data, analysis, we use, granite theory. So there is an example of, code as well. So that's starting from the raw data, then key point, code, concept. I would not go to the detail, but it's really fascinating how you do qualitative data analysis. It takes a lot of time and energy. So open coding, Excel coding, and then selective coding in that respect. And that's the way we identify the delays and then their strategies, how they were, addressing those their strategies. So then we came up with the reasons for the delays and the strategy they are using. So this is the one slide which cover almost the whole talk. So that's we identify the set of reasons and the delays, and then we identified, what are the strategies they were using to overcome them with the some areas successful and some areas, okay, so they were not very successful. So for example, you can see there, we categorize reasons into 9 categories, which I go in a moment over it. Then on the strategies are, then we identified the 17 strategies they basically were using, that in that aspect. So this is a taxonomy which we built. So for the reason, excuse me, if you see most of the research, if it's covering socio-technical thing, we need to deal with the technology, people, and the organization, because they build the context. So organizations build the context. So they take reason, the complexity of the patches, limitation of the current, tools, need for human intervention, which is required, coordination delays, then input requirement for the delays, failure due to the poor, planning and execution, organizational delay, and then capacity limitation, as well as the service agreement. That means whether you can take off the system or not when you are, building a system. So let me go over them one by one. So delay caused by the complexity. So when we're dealing with the patching and we're talking about more than 1,500 servers, so we're talking about different operating system, different version of the same operating system, different applications running on the system, and they all need to be understood. Not, basically immediately, because they are expert, they know that thing, but still a number of application, information may be missing. The new stuff is coming. So that means software, hardware, firmware, and what kind of version they are using, how they are interconnected, and then legacy system, how to deal with them, that need to be fully understood. And that was causing delay. Then faulty patch causing unknown errors during the patch testing and deployment and post-deployment issues. You have deployed the patch, and then the system suddenly started behaving unexpectedly. As a staff member, you might not know actually the patch has a error. You might thinking your system has a error. By the time you identify, actually this was a faulty patch which you ended up deploying on that, then you need to coordinate with the vendor. Okay, so then vendor basically, so you guys might have remembered there was a basically patch, then issues for Spectre and Meltdown. All patch needed to be having a patch. So can you imagine patching the patch? Okay, and then on the top of the patch, and those companies were not a small company. We're talking about Apple, basically, I mean, Intel, all those, and they have to issue the patch to patch the vulnerabilities which they introduce on that. So these are the whole issues. Security patches usually require extensive post-deployment monitoring. So sometimes it is months. So that's mean until unless you are fully satisfied, there is no basic side effect is coming on the system. It does not end up vulnerability introduction. For example, I mean, your colleague just mentioned about the coding thing, I mean, deep learning in the code. You are at the statement level vulnerability detection, which is some of the work done in Monash as well. So that means you are introducing new statement in the code, and that is causing the vulnerability. So is the case with the patch as well. You need to be basically very careful in that aspect. Then there is a strong feeling that when there is a vulnerability is issued, the patch is released, and you can imagine how frequently patches are being released. You can just think about your phone. Okay, every other day or every week, there is an update which overnight update that. And here we're talking about basically hundreds of servers, and they are dependent on the life critical system, the provision of the life critical services on that respect. Then, I mean, caused by the limitation. So here we identified, I mean, what are the limitations of the existing tool? No, if you are doing the scanning tool, you are doing static analysis, you're doing the dynamic analysis, and you would know that these tools tend to generate a lot of false positives. And then you need to manually look at that. And after some time, you stop trusting them because you think, okay, so how many false positives are there? And then you need to rebuild the trust. Okay, there are some basically areas which I'm getting still result in that aspect. Then you have a lack of scalability of the tool. So tool is developed and basically vendor basically telling you as a scalable, but once you try to scale that or to 2000 machine, certain critical feature are disabled. And then you realize that actually it is not scaling, it's a tool problem, nothing other problem. Then you need to scale back, and then you need to segment, make the segments, and then apply on that in that respect, in that scenario. And we also found inability to detect patch compatibility and the lack of compatibility with the multi-boot requirement. Excuse me. No, some patch might need, or some system might need multiple reboots. But if you have plan and you have the approval for only one reboot time, like a 4 hours, and the system need of multiple reboot, and the tool fail to detect that and tell you in advance before you get the approval to bring down the system, it's a huge basically delay in that respect. That so there is a code and investigation needed around the number of required reboot for EMR patching and window requirement as a result of if more reboots are required. So there is a quotation I would not read, but there are many quotations we verbatim basically reproduced in the paper. So then we also basically that identified human intervention. I think the better word we should start using, or many research groups have started using AI human collaboration. So that's been working together rather than either it's AI or human in that scenario. So we found multiple phases where they were introducing human intervention. So that means a full automation not available or desirable, faulty patches causing unknown errors, and then you need to detect them. And this is a manual process. This is, you do not apply the tools again, which have originally caused the fault, let the faulty patch go. Manual configuration of the selecting suitable group policy object. So group policy object means you cluster the similar kind of system or similar kind of patches, and then you do it as a batch rather than one by one, because that's a too basically effort intensive process in that. Human support may be needed for deploying complex, erroneous, and business critical patch installation. So that means where you really have mission critical system or human life related issues, you don't allow the machine to work in that aspect. So that's why human AI collaboration is going to work in the defense systems as well in that scenario, or any other mission critical system. Manual intervention for re-executing failed patch deployment and replanning patch schedule due to requirement. So if your patch has been failed, you cannot redeploy that until the next cycle. And next cycle is a 1 month down the road. That means 1 month you are leaving your system unpatched. And there is a security vulnerability which is already known via social media or via bug bounty program or something else. So this is a significant risk on that. And then you need to negotiate that, can we do something out of patch window, in that respect. Coordination issues, again, we have a whole paper on that. So, but to briefly, there are internal and external stakeholders involved, and they share, they need to share a lot of knowledge and a lot of information about the patch, release, then what preconditions are, how to deploy that, and then which task is this. If people are working in silos, the progression on the basically task, not available. So then you have to have a basic understanding of the shared responsibilities as well as, who is doing what. In this particular organization, we are not aware of others. Email was the only mechanism for communicating. And just imagine that if one email goes missing or unnoticed, quite a lot of information lost, and other people are dependent on that information in that scenario. So again, I don't know what the reason is they are using email. There could have been more sophisticated solution are available. Then customer, end user, vendors inefficiently coordinating for seeking and giving approval for system downtime and verification. So again, there are there is significant research has been done in the software engineering area, even, for example, in the global software development area, other phases of that, which can have some lesson, some solution to be brought into this patch management thing to make this collaboration more efficient, and the CSCW community as well. No, patch management is very tightly, basically intertwined process. So one phase of the outcome is needed by the next phase. So for example, team which scan the system is different to the team which is going to assess and prioritize the patching, because you don't treat all the patch, even the security patch, equally. There is a whole research on coming in the software engineering area, how to assess and prioritize vulnerabilities when you do the prediction models and all kind of thing. So if I am the scanner and I forget to provide the timely report to the assessment team, it is going to delay that. At the same time, there, for example, if we have a requirement engineering area, there are prioritization research, very extensive research, many years. However, in the security patch management, methodologies are not available yet. So that means how to prioritize that, whether it is operating system is going to prioritize first, or some critical application is going to prioritize first, how long the window is available, which customer is stubborn, is not allowing you to bring down the system, and you need to think about that. So there are a number of issues which we have identified, but yeah. Non-delivery or incomplete delivery of the schedule-related information resulting in poor planning and deploying patches. And then delays in receiving vendor support for patch errors. So that's been one, once you have detected the errors or you need information, but vendor is not dealing with you only. Vendor dealing with the whole raft of customers, client, they have their own service level agreement in that aspect. So there we also saw quite a number of challenges being faced. Then poor planning and execution. Again, security patch management need meticulous planning and flawless execution, as I mentioned at the beginning, in order to avoid the breakdown of the system. So that means patching is just one particular activity. So we need to focus on the task and the subtask, because subtasks usually cause the delays, and they also cause the failure if not pay full attention in that. So if I am planner and I inaccurately estimate the time required, And that is going to improve. That is going to be part of the service level agreement. That is going to drive the some system coming down and the service interruption to the critical service of the patient. Then I am not going to go back and say, I agree with you 4 hours and no, I think we need 8 hours. What are we going to do with the patient whose surgery has been scheduled in that aspect, right? So would be the critical system in that aspect. Yes, please.
So my question would be, wouldn't it be better to, let's say, push an update that just rolls the system back to the previous version while the patch is being worked on? Because let's say you don't need to do much work to just like roll back to this previous version, and then you just release this new feature once it's ready, instead of just leaving the system vulnerable while you work on the patch. And if that's not done, why that's not done?
Yep.
That's my question.
It's a very good observation. Thanks for that. And actually that comes under their strategies. So they are doing basically, rolling back. They are looking into server back, and no, there is not much time left. So I might skip a few slides, but you have pointed out a very good strategy. Organizations are using that strategy. Thanks for that. Yeah, I might not have a time to go over that part. Okay. So unforeseen error can become major risk to deploying within planned time, and incomplete patch deployment or insufficient verification needed to re-execution of the patch deployment and operational disruption. So that's when you have to verify the patch working everything correctly, that might last longer than you anticipated, and then you need to do the better planning in that aspect. Policies and procedures. So if you are in the regulated industry, like a healthcare is a regulated industry, procedures and policies are huge. And by the way, don't take my word, it's recorded. I shouldn't say that thing. Actually, education is also becoming regulated industry. How you can use credit card, Airbnb or not, blah, blah, blah. Okay. So we are also in a very regulated industry, a lot of policies, a lot of procedures. I'm known for, asking, pushing back. Anyway, so changes in the organization schedule, such as change freeze period. So that's mean if, yeah, please. Yeah, please go ahead.
Back to the previous version. So let's say if like Apple, for example, when they release a new iOS, for example, firmware. So let's say, and if it has a security problem or security patch, how would they roll back, to the previous version of all the users? It's not always easy as it looks. So yeah.
Yeah. So I think, this is a very good observation as well. And I'm going sidetrack. Actually, UK National Health Service, they could not even roll back because the virus has gone to their basically backup as well, because they did not do the segmentation of their backup as well. That is a basic thing. You do not basically back up the fully. So the virus copied on the backup server as well. So it's a very good observation. So that's why you do proper segmentation and then you do the backup in that way. It was a side comment, but let's me get back to the talk. Yeah, thanks. Okay. So yeah, policy and procedure to be followed. Capacity, limited capacity. That organizations are already struggling. This is what they call it. It's called great quit, or what is called quite quit, right? So people are leaving, they are finding other job, or they're doing 2-3 jobs. With the COVID-19, the other day time zone, I was giving a keynote, a workshop in USA time zone, and I realized actually I can do full-time job in USA as well, because if I'm awake until 2 a.m., so it's quite possible, and there may not be any jurisdiction for that. So the capacity limitation we found in this instance, it's not only human being. Let me tell you one thing, insufficient infrastructure also can cause a problem. When you're running the testing the patches, then you have to do a verification. Just imagine, don't take it criticism, please. I'm a PhD student working in the machine learning area, right? And they don't say that when you have a centralized server to build your model and run that one, and you have a XC deadline going on, that infrastructure is not working. There is a queue is not there. So that's mean what we're talking about is here we also see infrastructure problem, and they also, that's mean the networks were not available. They have a congested problems and all the hardware in that. So again comes the better planning thing. Testing the workaround for failed deployment delayed for weeks given the time driven. So that means you have to wait for 4 weeks for the next cycle. Service level agreement, you need to agree with the end user, which happen to be the health service provider, like a doctors, nurses, hospital administrator, that how long you need to bring the system down. To basically summarize this finding, we are doing a project with them, with the same organization, to automate the runtime patching. So that means the idea is that you automate their runtime patching solution, developing that, and that project is finishing after 2 years. Basically, we have had success in that aspect. But again, there is a human being. Okay, so then we also figure out that which area frequency for the reason. So most of the coordination delay, 24%, and then the input requirement delay, the people are not doing their task, and then the other people are waiting for their task in that aspect. So if we do build the pipeline with automation support and human interaction, that can be one basically supporting area. And then we also figure out that there are phases, and which phase delays happen the most. And then we saw that when batch information retrieval is getting 54%. So that means you get to know the patch is available, vulnerability is there, it takes time. So that can be done, there are different ways. There are social media based approaches. There is as I said, subscription based service in that respect. Okay, so I'm mindful of the time. There are strategies, 7 strategies. I'm not going to go that, but let me explain you here on one picture in that respect. So we identified some strategies are overall process, and some are on different phases. So overall strategies are frequent communication, collaboration, decision-making, task delegation, regular review and update of patch management process, related documentation. So these are all 4 which are causing the delay. And trust me, they cause the delay and problem in other phases of software engineering as well. And trust me, as educationists, we don't train the student in that one. Or students don't want to be trained in that aspect, because the only thing they want is coding. So many times I say, listen, that one, how I got in Google as a self-taught software engineer. And I'm thinking you can be self-taught programmer, but not self-taught software engineers. So that's why in Canada, there is a move going on. One agency saying, you stop using the title of software engineering. In that, there is a big fight going on. I think it's a state is called, I forgot the name of the state, but there is a big fight going on. So coming back to that is these 4 things: frequent communication and collaborative decision-making, task delegation, and regular documentation. They are challenging for the whole process in that aspect. So starting from other strategy relating to the patch information retrieval. So set strict guideline. All the vendors have specific 2 days of patch releasing, as a weekly or monthly. So as a security personnel, you are supposed to go and check those, what is the information is, what are the updates. So there can be pull and push, both kind of strategy can be applied. Then you can subscribe to the basically paid services. There are paid services in that respect. There are in-house tool can be built which can scan the social media and does the analysis. You might heard of the company called Fivecast, which came data to decision CRC. They initially they did that kind of work, and now they are looking into the dark web. So there are many companies available. Strategy relating to vulnerability scanning, assessment, and prioritization. So this is the area which need to, a lot of work need to be done in that respect. So what we observe here is, they're trying to prioritize based on the operating system and as well as the mission critical area which they work in that respect. So there need to be some definition of the priority. What are the priority? How those priority can be considered and cater for that. The strategies relating to the patch testing. So define compliance policy and contingency plan. for the test failure. So if there's a, because you test the patch first and then you go to the deployment stage, and there has to be some proper support in that. So then identification of the patch, requisite investigation beforehand, rather than you start the patch process. And that's mean all those information is coming to, to gather, modify software configuration and dependency in that aspect. So by looking into that, there is a concept in the, that GAI community, it's called activity-based computing. Activity-based computing has been very successfully used in the medical, where they have a information provision of the information for operating theaters. I see quite a lot of room for activity-based computing in this kind of thing, because the whole idea is to providing the information at the right time to the right person in that. And strategy relating to the patch deployment, again, timely coordination and all kind of things. So you can read the paper, but what I'm gonna quickly go through that is, okay. So if you are a practitioner, what our research does is providing you the information. It is providing evidence-based understanding for the reason for delay. So rather than you learn by trial and error and through anecdotal evidence, it is providing the evidence that these are the reason for delays, and you can be much more informed. You can do the better programming in that aspect. So you can have a proper decision and prioritization decision and the planning decision. Then it also can basically, the strategies which identified can guide the practitioner organization in a better planning and taking action to mitigate the impact of the delay. So if you know certain things are going to cause the delay, you are ready to basically cater those delays in that aspect. And developing new and innovative use of the existing tools. So what we see, the research we have done, this research can also be used as the requirements for either enhancing the existing tool or developing the new tool to support the security patch management. So what is for researcher? Well, this is a one case study in one organization. It's not generalizable. It's one company, health agency and one sector. Other researcher can take the protocol and try to replicate either in the same domain or in a different domain in that aspect. Some researcher can take the finding and design the interview instrument as well as the survey to verify and find the new findings in that aspect. Research on AI-based tool for detecting patch mismatches, improved coordination across patching tasks and reducing the delays, and investigating the suitability of human AI collaboration for security patch management in that aspect, and evaluating the performance of the accuracy of the tools. Again, I mentioned too many, that false positive, how to address them. So that is another area which can be looked into that in that aspect. By the way, this is a research team. Nisara, Asangi, Mansoure, and I'm at the last. So in CREST, my team, we have a, I don't know, we have a balance or imbalance in that. So in that scenario. So Nisara is leading the project. Asangi and Mansoure are supporting them, and I'm there to contribute and present the findings like that. Thank you very much. There are 7 minutes. I mean, if there is some question.
Yeah. Thank you very much for your very interesting talk, Professor Babar. I think we have some questions from the Zoom audience. I'll start with that, and the others in the room can think about their questions. The first one is by Victor. The question is, to what extent improving the associated patching tools would reduce the delays? Wouldn't similar delays stay because of lack of trust towards the improved tools as well?
Sorry? I know what extent they delay, they reduce the delay, right?
Yep. And wouldn't similar delays stay because of lack of trust towards the improved tools?
Well, I mean, it depends, because there can be another study, because as I mentioned, performance of the tool need to be evaluated. So it's not only the performance of tool, whether they are delaying, reducing the delay, and how much they are delaying. So every tool we use, we need to do the trade-off analysis as well in that aspect. Excuse me. As well as trust is concerned, trust is slowly built. You know, I mean, when you introduce a new tool, trust is slowly built. I mean, whether it's an individual working for, you know, I mean, I'm using my organizational system. Most of the thing is done on tool, you mean online, from booking to everything, right? Yeah.
Yep. Thank you. There is one more question. How did you prioritize, or the science behind the reasons for failing patch management?
How to prioritize? Science?
How did you prioritize the reasons for failing patch management?
Yeah. So what we have done is we have given a battery of basically reason. Now, how they need to be tailored and prioritized in the organization. That means you can't focus on all the basically 9 categories, and each category have a different reason on that. So it depends. So the idea is it is evidence-based knowledge, and know how I'm going to interpret and how I'm going to deploy in my organization. That is a very much dependent on the organization and individual, different individuals.
Thank you.
Hi, thank you for your talk. So I have one question about the delays caused by patch deployment. So as you mentioned in slide 19, so we have patch in software level of firmware or hardware. So in general, we think it takes a long time for hardware patch, and the firmware level comes after, and the software maybe is the most efficient one. So I wonder, are there any statistical data to show the exactly delays caused by the 3 levels? Yeah.
For this study, we use all the delays equally, and we did average delay. What you're mentioning, that's a very fascinating research to do deeper, you know, I mean, the kind of delays happen and the kind of systems. It's a software system or it's a hardware system? Yeah, thanks. I mean, that's a very good question. But for this research, we did treated all the delays equally and then did the average on that. It's a descriptive, you know, I mean, yeah.
Any other questions from anyone?
I'm thinking we can talk more over lunch, but it's just a fascinating talk, Ali. I really enjoyed it. And there's just so much to take from that. I'm just wondering, a lot of the activities have to be done urgently. And as you say, they're all in silos as they move things across. And of course, when we're anxious, we know that we don't have as much mental capacity to think and produce as well also. And I'm wondering, does your research have a lesson for organizational change? And I'm thinking about, you know, with social identity theory and the in-groups and the out-groups, when you're in your little silos, you're thinking about just yourself and your group and not the bigger group. Do you think that your work could be used by others to really rethink how organizations work and as teams? And yeah.
Okay, yeah, I think, I mean, this is a good question. No, if we talk about social technical system, we need to think about this area draws, I mean, from researcher on the work design, how the work need to be done, how the work organized, basically how the team need to be organized, kind of thing. Information system, CSCW, and the last one is basically, I think, system engineering in that aspect. So what, Monica, you mentioned, that's a very good question, and they need to be done. So again, you know, I mean, as an interdisciplinary researcher and my colleagues there, we have to remain within certain boundaries to because you know that, I mean, I'm older, they are younger, they still need to go to their tenure and everything. So they can, I think, unfortunately, interdisciplinary research is appreciated, but I'm not sure whether in the tenure we have changed or not, because we still focus on where publishing, what they're publishing. While you bring the other people on board, they, from my approach is always, okay, that's okay where you want to publish, but not basically when people are young, when I was young researcher or kind of thing. Yeah. So we need to think, I mean, yes, I mean, the people who do the work design, organizational psychologists and social psychologists, they can certainly play a key role in helping the organization to do that. Because no, you can see because of Optus event, as cybersecurity suddenly gone visibility, right? But this is important. This was the important area before that as well. And if the attention, slightly lesser attention would have given earlier than that, then there would have been solution before that as well. So I think, I mean, it's a hype cycle. It will go down. I mean, people will forget they lost the data.
It's really interesting that you say that. I think it's more of a problem for Australia than the UK as well. This idea of this FOR codes and the ERA is a very different judgment call to the ref, for instance. Although I have hope that, you know, Australia will advance and see things differently, but also our journals are becoming more interdisciplinary just because they have to be, right? So, yeah, but I can see that problem, but it's great work and
thanks. Actually, it's right on dot. We are starting a new project, it's called Socrates. It's focused on software security, funded by Cybersecurity CRC. So there are 6 research providers and 6, industry and the government agencies. So what, small talks which was presented, Monash, most of these topics are covered on those in that project, ranging from, quantum, post-quantum, it's a supply chain. Supply chain is a big issue now. Then is data quality, security data quality. If you're building the model and the data is not available, and then the other thing is we are computer scientists or software engineers, we are very strict to ourselves in many cases, even in the methodology side thing, because I not maybe my colleague, but I favor fiddling with the methodology. I mean, come on, I mean, that basically sometimes if you are too much focused, that sometimes you might not end up doing the research. I mean, for example, in that aspect. So coming back to this point is that project covered probably there are 8 work packages, even starting from the responsible research innovation and the legal aspect of that. So that project also provide a number of interaction and collaboration in that aspect as well. And thanks for the opportunity again.
Thank you very much for your very interesting and insightful talk. And thank you everyone for tuning in. That's the end.